Our course is design and analysis of algorithms, and here we will see the some notion of the algorithms. And you know that algorithm words is used in other subjects also. So it simply means that the steps you are going to follow for completion of some task. In computer science, we mean algorithm. Once you say that this is the algorithm, it means we are writing the algorithm that can be used for solving the problem with the help of our computer. So here we will use the computational model for solving the problems. So some books refers that an algorithm is a finite set of instructions which, if followed, accomplishes a particular task. So an algorithm is the finite set of instructions. Here you can see that this word is finite. Set can be finite or infinite, you know. So here we mean that an algorithm must be a finite set of instructions. Why we ensure the finiteness? So we don't want our algorithm should contain the infinite instructions. Why it is so? As we believe that for execution of every instructions in our computer, it takes some time. Okay. So if you have the infinite instructions, this means your algorithm will take infinite time for completions. So with this intuition, actually, we believe that we should ensure that our algorithm should have the finite set of instructions. So here, an algorithm is a finite set of instructions which, if followed, accomplishes a particular task. And this says that in the set of instructions, we have some particular sequence, you know. So if you are going to execute in that particular sequence of the instructions, then you will have some task. You can complete some task. So this is the notion of actually algorithms. So besides this, actually your algorithm should satisfy some property, and we can say that every algorithm should take some input. So this is one of the property of your algorithm. Other one is, you can say, output. Then you can have the definiteness. Okay. Then your algorithm should have the finiteness property also, finiteness. And your algorithm should also be the effective. So you can say that effectiveness. So in addition to this definitions, where we say that an algorithm is a finite set of instructions which, if followed, accomplishes a particular task, your algorithm must satisfy these properties. So every algorithm should satisfy these properties. One is what? Input. Your algorithm must take some input, and you know that your algorithm will take some input, and once it takes input, you are expecting some output. So if you are going to say that, okay, your algorithm should take some input and it is giving some output, then actually this is the we require actually. That's why we say that accomplishes a particular task. So output must be there. Without output, you can't say that, okay, you are doing some job. So input and output, sometimes you can have one input, or you can say supply more than one inputs. Output can be one, or you may have the set of outputs you can produce. Definiteness property of the algorithm is very important actually. Definiteness property of your algorithm says that every statement of your algorithm must be clear and unambiguous. So this is very important. So every statement of your algorithm must be clear and unambiguous. Okay. So like in your programming language, every statement of your programming language is clear. You know that if you say that a plus b, c is equal to a plus b, and it is clear that you are adding the values from a and b, and your result is going to store in the variable c. So this is clear. If you say that C is equal to A or B, means you can assign the value, you can store in the value either A or B. So what you mean by, in generally we will say that if you say that C is equal to A or B, it means C can hold the value either A, or C can, someone can say that okay, I will store the B in the C, someone say that I will store A in the C. So this kind of statement we cannot execute in our present programming language, as this statement is not clear. Your computer needs to make the decisions, and you know that we have studied the finite and computational models, and we have seen the Turing machine. When this kind of decision comes, when machine is supposed to take decision, then this is the case of non-determinism. So this is the non-deterministic statement. And what we mean that once your statement is clear and unambiguous, this means we want that statement of your algorithm must be deterministic one, because non-deterministic algorithm, if you have the non-deterministic statements, then your present programming language cannot handle such kind of instructions. So once you say C is equal to A or B, this means in general our intuition is to store the value of B in the variable C, or you can store A to the C. But computer cannot make this kind of decisions. Computer will clearly ask you that okay, what you want, whether you want to say that C is equal to A, or whether you want to say that C is equal to B. So this kind of statement must not be there in your algorithm. So that's why this definiteness properties must must be satisfied by every algorithms. Now we have the finiteness property. In the finiteness property, what we ensure that your algorithm should contains, already I have told you that we must have the finite number of statements, finite number of instructions in your algorithm. So once your algorithm is going to execute, then your algorithm in all possible inputs, we believe we should ensure that your algorithm should terminate in reasonable amount of time. This is our intuition. So finiteness property of your algorithm ensures that your algorithm should terminate in reasonable amount of time, because finite amount of time can be anything. So here we say that the time should be reasonable to complete, and simply meaning of this is that your algorithm should not go to the infinite loop. Means if it goes to the infinite loop, then you are not getting the response, and if you are not getting the response, this means your problem becomes intractable. And once your problem becomes intractable, means you cannot see the behavior of your solutions on behalf of some particular inputs. So on behalf of the some particular input, your algorithm, what we believe that our algorithm should terminate in reasonable amount of time. This is the finiteness property. And effectiveness means what? Effectiveness property of algorithm says that every statement of your algorithm must be basic enough so that we can compute with the principle of pencil and paper. So means your statement of your algorithm must be effective. Means you should like effective means you can compute every statement should be every statement must be computable. Like if you work on the integer arithmetics, then dividing 10 by 2, we can compute with the help of pencil and paper. While you are working on the real numbers, then some real numbers may be expressed after the decimal point. Many possible, say 1 million or 2 million points after the digits after the decimal point. And this kind of, if you are working on the real number, then this is not the effectiveness. So what we believe that your statements of your algorithm should be effective enough so that we can compute by principle of the pencil and paper. So this is actually we are going to ensure. If your algorithm is not going to satisfy the definiteness property, then you, with the help of the present programming language, you cannot implement your algorithm, and such algorithm are such algorithms are known as non-deterministic algorithms. So here, whatever we are talking about the deterministic ones. So whenever I say that, okay, write an algorithm for this problem, this means you have to write the algorithm for some, you need to write the deterministic algorithm. And in case of the deterministic algorithm, you know that every statement of your algorithm must be clear and unambiguous, and statement of your algorithm should also be effective so that we can compute with the help of pencil and paper, and hence we believe that machine will able to compute it. So your algorithm should have these 5 properties. Your algorithm should take input, it should produce the output. Your algorithm should have the definiteness property. Every statement of your algorithm must be clear and unambiguous. Your algorithm should terminate in the reasonable amount of time, and statement of your algorithm must be effective enough so that you can compute it with the help of pencil and paper. So this is the property of your algorithm actually. And you should know that algorithm is not an English word. So it comes from the Persian author Abu Jafar al-Khwarizmi. So algorithm, nowadays algorithm, we are using the word algorithm to mean the computer algorithm, means we are using the computer to solve the problems. Okay. So if your algorithm has the definiteness and effectiveness property, then this is also known as the computational procedure. Computational procedure. So whenever you have the definiteness and effectiveness property, then this is also, you can say that this is the computational procedure. That's why in Coleman book, you will find the definition of the algorithm, and it says that an algorithm is a computational procedure. So once you say your algorithm is a computational procedure, this means your statements of your algorithm, means your algorithm can be computed, means this is the computational procedure, means you can compute with the help of pencil and paper, means you have some algorithms, okay, you have some algorithm and you are supplying some input. If you supply some input and you are getting some output, okay, and then you can, means if it is the computational procedure, then you can transform this input into the output with the help of the statements of the algorithm. That's why this is the computational procedure. So you know that the transforming the input into the form of the output, we have already seen in case of the theory of computation, when you are going to transform the input into the form of output, this is known as the computational procedure. So you are going to compute, and every statement, how you are going to transform the input into the output, for that actually you are writing the statement. This is the set of statements in your algorithm you are writing, and you are computing one by one. So every statement of has some kind of, it takes some preconditions, and precondition means it may take some input, and it is going to produce, after completion of the statement you will have some response, it is going to transform in some output. Then after completion of this statement can also have some precondition, and it, after completion of this it may start computation of the second statement, and it can also produce some output. It can also take some input and produces some output. Likewise, one by one actually you are marching towards the solution. So whenever you are writing the statements of an algorithm, and if it is the computational procedure, then every statement is computable, and one by one your statement is going to execute, and you are marching towards the output of the algorithm. That's why in this way you can say that you are transforming input into the form of output. Okay, so this is the case. So now this is the notion of your algorithms. In the research area of algorithm, we have the different area of studies in connection with the algorithm, or we can say that the aspects of algorithms. Okay, so we have the several areas you can see algorithms and theory of computations. These two subjects, you know that they are actually they are the field of research. So in connection with the algorithms, the first challenge comes is that how to how to devise algorithms. This is the first challenge. Second area of study, you can say that how to validate algorithms. Okay, then you can say that how to analyze algorithms, and then you can say how to test program. So in connection with the study of algorithm, we have the several fields to study. One is how to devise algorithm. See, there is no ready-made tool or procedure available that you can use for devising some algorithms. Depends on the problems, depends on the situation. You will have to use some design techniques. Every time you can say that one design techniques or every time one method may not work for all kinds of problems. So this is one of the challenge, and this is still the open research problem in connection with the algorithms. How to devise algorithm? This is the challenges. So here actually we in this particular course we are going to study some design techniques. That's why I told you that we are going after analysis, we will move to the design and analysis of algorithm. Designs means we will see that what are the techniques, basic techniques we will have for designing the algorithm. Some techniques we are going to study here is divide and conquer. You have already studied in the data structures whenever you have written the program for quick sort and merge sort. Next we will go for the greedy method. Okay, then we will go for the dynamic programming, and then we can go for the backtracking approach, and we will go for the branch and bound approach. So in this particular course, in our algorithms, we are going to study the notion of divide and conquer techniques. We will go for the greedy method, then we will go for the dynamic programming and backtracking approach and branch and bound. These are some techniques that we are going to study in this particular course. But see that these are not only design techniques that covers all possibilities. Depends on depends on the algorithm or depends on the situations or problems. Sometimes you will feel that okay, divide and conquer is applicable. Sometimes you may feel that greedy method is applicable. Sometimes you may feel that dynamic programming is applicable. Sometimes you will see that backtracking approach is useful or branch and bound approach is useful. And in some problems, even you may find that none of these techniques can be applicable. If none of these techniques can be applicable, then you have to think that can you combine the two techniques for devising your algorithms? Means can you mix up the two different techniques for your problems, or whether you are able to generate some new techniques? Can you devise some new techniques if your problem cannot be solved with the help of divide and conquer, or problem cannot be solved with the help of greedy method, dynamic programming, branch and bound, and backtracking approach? Can you see that? Can you devise your own techniques? So that's why this is one of the still emerging research field where we need to devise we need to devise algorithms, or we need to formulate the solutions of the challenging problems or real life problems. So here, after studying of these such techniques, divide and conquer, greedy method, dynamic programming, backtracking, branch and bound, you will come to know the behavior of these techniques. And behavior means you will have the computational judgment of these techniques. That's why whenever you have in situation to use the design technique, if you are in the situation to select the design methods, then you will have in mind that okay, which design technique is best suited for your applications. Because if sometimes it may happen that divide and conquer technique works well, whereas dynamic programming or greedy method is not going to work well. So in some situations one technique is suitable, and for some other situations some other techniques may be useful. So that's why every time we should not go for the brute force approach. We have to clearly analyze the problems, situations, what in kind of input your problem is going to receive, and what you want actually, and what is the behavior complexity of your problem, what is the behavior. And on behalf of that, you are supposed to see that whether you can go for which techniques you will need to go. Okay, so after studying of these basic techniques, you will have clear in mind that you will be able to use such techniques in different kind of situations. And if unfortunately if you are not able to use even these techniques, then how you can devise, you should have the capability to devise some new algorithms based on your study, or based on your experience and knowledge and your literature study. So this is one challenging task. Assuming that you have developed the algorithm, now the next challenging task is how to validate the algorithms. So the next emerging field is how to validate the algorithms. This means what? At this time, your algorithm is not implemented, or it is not transformed into the programming language. You have written some algorithms. Now actually you need to test whether your algorithm works well for all possible legal inputs. It should not happen that only your algorithm is going to work for some few inputs, and for some other input it may not work. So this is also one of the challenging tasks, and this is also one of the area of study where you have to deal with validation of the algorithms. You need to validate the algorithm. If you say we have the number of searching and sorting algorithms available, if you have some experience, based on your experience and knowledge, if you are able to devise some new sorting techniques, then you need to first, before reporting these techniques, you need to first validate these techniques. Means you need to know that if you are going to supply all possible legal inputs, whether your algorithm is going to return the correct values, correct output or not. This is important. And this validation is not a simple job. Whenever you go for the validation, this is not very simple, as sometimes input of your algorithm is not finite. It may be the infinite input. Your algorithm may take infinite input, and it may happen that for a small input your algorithm is going to execute, and it is going to produce some response. And but for some other input your algorithm may be busy with the computation, and you don't know what is the output of your algorithm. Then this is the very difficult task to validate the algorithm. But for that you can use the concept of the mathematics. Means you can go for the writing the theorems, in general theorems. If your algorithm is working for the n, then it may work for the n+1. Okay, or you can use the mathematical induction to prove this theorem. So you have to develop some techniques for validating the algorithm, and this is also one of the very, very important area of research. Next challenging one is how to analyze the algorithm. Now, until this point also, you have not implemented in any programming language. You have written the algorithm. Now you need to analyze the algorithm. So first one, you have seen that you have come to know that how to devise the algorithm. You have come up with some sort of the algorithm by using some techniques, or you may have some own techniques. Then next, your task is to, whatever algorithm you have devised, you need to validate it. Means you need to find out its correctness, whether it will run correctly for all possible legal inputs or not. Then you have to go for the analysis. And once you go for the analysis, actually, then you are going to position your algorithms. Say if you have the number of algorithms already exist for the same situation, some particular problems, then why people will use your algorithm? So you have to give the analysis. Your algorithm must have some benefit over the existing one. So analysis of the algorithm is very important. Analysis of any algorithm is not a simple job. For every algorithm, you require some different kind of skills and different kinds of experience. Sometimes your algorithm, we need to optimize one parameter. Sometimes we need to optimize more than one parameters. Depends on the algorithms and applications and its nature. Like searching and sorting problems, we are more focused on the comparisons. So we have to optimize the number of comparisons. So how to analyze the algorithm? This is also one area I've studied, and unfortunately we don't have the any ready-made software for this, so that you can use for analyzing the algorithm. It will come by experience. So in your experience, and if you see more and more algorithms and go for the analysis, then it will develop the skill. You are going to develop the skill to analyze the algorithms automatically. Analysis of algorithm is very important. With the help of the analysis, you will be able to know, without executing your algorithm in your system, you will be able to tell the people that what is the computation time your algorithm will require, what is the amount of memory your algorithm is going to require. Means whatever resources of your algorithm is going to use, you need to analyze here that what are the resources, what resources are required for execution of your algorithm in best case and also in the worst case. Means if everything is in favor of your algorithm, what is the minimum number of resources needed, and if your input is not in your favor of the algorithms, then what are the worst case resources your algorithm requires. So you have to present the computational behavior of your algorithm here, and with the help of this computational behavior, actually you are able to position your work. Then you are telling that, okay, this is the importance of your work, and this is the advantage of this algorithm over the existing one for the same kind of problem. So here you need to positioning the algorithm, means you require to discuss the resources that your algorithm will take during the execution. So this is one of the very, very important topic. Now, the fourth one is how to test a program. This is for the your lab work, how to test a program. So, in how to test a program, now your algorithm should be expressed in some programming language. Now you are going to implement your algorithm in programming language, and then you are going to execute the programs. And how to test a program, this is also one of the very difficult tasks, as sometimes you see that your program is running and it, it has no bugs actually. So if there is no compilation error, no bugs, then, and if your program is running and for some input, if you don't have the answer, you will not be able to know that whether you are getting the correct output or not. So if you have some compilation error, some syntax error, then your compiler will generate the errors and you can debug. Means if you have the bugs in your program, then you can debug. But if you have the logical mistakes in your algorithm, if there is no bugs but your answer is not correct, so it is very difficult for the, it is difficult task to verify whether your program is running correctly for all possible inputs. So this is the computationally hard problem in computer science for testing a program. Some hints you can take if you are solving the some say some new problems, and if you know that the group of persons are working on the same area, then you can see your result and you can see also their results, and you can match. If if the persons are working in the same area and they are also providing some solution, and you are also going to formulate some solutions, and if your solution is nearby those, then you can say that somewhat you have the clue that okay, you have written the correct program. But it is also, again, this is one of the difficult tasks to test a program. Here what you need to do in the labs work, you have some algorithms and you need to write the programs for the algorithms. Like you can take the algorithm for the quick start. Okay, you may have the you can say quick start, or you can have the merge start. Say for example, you need to write a program in your lab, and you see that what is the time for the quick start, what is the time for the merge start. Means you have to go for the profiling work. Profiling work means here whenever you are going to execute a program, you need to do the profiling work. Profiling work means you need to say that this is the input, and for this input your program produces this output, and this is the time. So on behalf of this is the input and this is the time. So this is the profiling work. So for the case of the quick start, if you say that okay, when n is equal to 1000 elements, for example, your quick start time is this, whereas your merge start time is this. So you can plot a complexity graph. So you may come to know that okay, you may have some kind of graph here. Okay, for the long input size, this may be for the quick start, and this may be for the, say for example, merge start. So when, say for example, you may have some point here, say for example n0, and you need to determine what is the point. This is known as the break-even point of your algorithm. This is the break-even point. Okay. So break-even point of your algorithm will tell you that after this point, this algorithm, maybe your situation may be like this. Here you may have the merge start, and here you may have the quick start. Means you may have some input, say maybe roughly you need to determine actually this, what should be the break-even point. Once you are going to execute the algorithm, you need to know that after which points, say merge merge start algorithm will take more time and your quick start algorithm takes less time. So at the beginning it may happen that your merge start may require less time. Okay, and then after some points your merge start is going to take more time as compared with the quick start. So say this is the profiling work actually you are going to do. So you may come to know that okay, once you have the 1 lakh element, after 1 lakh element, if you execute the merge start and if you execute the quick start, then for your system merge start takes more time as compared with the quick start, and here is the time. So this is important. So once you are executing the program in your system, executing the algorithm in your system, then the advantage of this is you know the behavior of your system. This is the exact analysis actually you are going to do. Means you are, for your system, for your architecture, for the available memory, actually you know that if you have the two algorithms, say for example quick start and merge start, and if your application comes for the starting purpose, somebody gives the element to sort, which sorting algorithms you will need to apply. So in your system, it may happen that merge quick start may take less time for the large amount of elements. Say somebody, if you come to know that okay, I have the behavior of the system in your computer is you may come to know that after 1 lakh elements, your merge sort takes more time as compared with the quick sort. So once somebody gives you the 1 million element to sort, then surely you have to go for the quick sort instead of the merge sort. So in this way, you will know the behavior of your system. So in your architecture, your computer memory, and your available hard disk, your resources, you are going to do the exact analysis here once you are going to write a program and you are doing the profiling work. So you will come to know that depends on the input, whether your input is large or whether your input is small, then which, if you have more than one technique available, means sorry, more than one algorithms available, then which algorithm you need to prefer for your system, this will help you. You need to see the computation time for your system for all possible operations. Like you may have the multiplication operation, okay? You may have the addition operation, you may have the division, you may have the assignment, okay? Assignment, jump operation you may have, and you are running the for loop and you are stating that for I is equal to, say for the 1, 2, and this is the control part of your for loop. What is the time for the control part? So at the beginning, actually, you need to know the computation time for the operations of your algorithm. In your algorithm, you need to know that what is the time your algorithm takes for the multiplication, what is the time your algorithm takes for the addition, what is the time your algorithm takes for the division, assignments, jump, or initialization, or control part of your loops. And you may be calling some function, then it may require some function calls also. So what times you require for the function calls? So if you know the behavior of all such operations, then you don't even without executing the program in your computer, you will be able to tell that what is the computation time your algorithm will require. You just count the number of operations. Okay, this is the algorithm. So this much number of additions, this much number of multiplications, or this much number of assignment, divisions, control part, and accordingly you can compute the time. So actually you should know the behavior of your system with respect to the different kind of operations. In some systems, multiplication may be cheaper, or in your system, multiplication may take more time. If your multiplication takes more time, and if in some algorithm it requires more number of multiplication, like in matrix multiplication, then it may run slow. But if your multiplication takes less time, then such problem can solve quickly. So that's why it depends on the architecture of your system, depends on the resources and devices and availability of memory, processors, speed. Your algorithm may have different exact time as compared with other machines. So whenever you are going to determine the exact time for the programs, this time is for your own, only for your machine. It is not, you cannot make a general comment that okay, the algorithm A requires this much millisecond or microsecond time. This millisecond or microsecond time required in your system, not for others. In other systems, it may have different architectures, different availability of memory, and the algorithm may run fast or algorithm may run slow. Okay. So, so these are the four challenging area in connection with the study of algorithm.